Woohoo! Welcome back. Today we're going to be talking about more chain rule examples. Yay! Woo! But before we start with the chain rule, we're going to have to talk about composition of functions or outside and inside functions. So I've got two examples set up and we're going to practice figuring out what's on the outside and what's on the inside. And I'm going to remind you that generally speaking, mathematicians name things the way they look, the way they are. And so when we say outside and inside, we really mean outside and inside. So for example, if I've got this set of parentheses with a 4 exponent on the outside and 3x squared minus 5x, that's on the inside. So literally the outside and the inside just look like that. So for the outside, I'm going to use blue. And that's going to be the 4th power, or the exponent with 4. The inside is going to be this expression that is literally inside the parentheses. So frequently just look for the parentheses, and whatever's on the inside of the parentheses, that's the inside function. Now, the problem is that then mathematicians go and muck up all this simplicity with a little bit of formality. But it's something you can practice and you can kind of get the hang of. So if I want to use u of x as the inner function, then that just means I want u of x to be 3x squared minus 5x. So u is going to be the inside function. Woohoo! So you can start with the inside. Now we have to think about, once we remove this, what's left? And what's left is, I'm not quite, my fingers are either too big or too small, but basically if you cover this up, you just have the 4th power. Now, some books will tell you just to go ahead and write out the expression or the function like this. But the book we're using says, no, that's too confusing. So they want to bring in u. And all you're going to do is you're going to take that x to the 4 and write it in terms of u. So it'll be u to the 4. Does that make sense? So basically, I pretended that the yellow was hidden. I put a big U over that. Oh my goodness, I just had a brilliant idea. Let's see, can I do this mid video? Let's see, this is preparation in action. It's actually inspiration in action. So we've got this function. If you take the inside and you cover it up with a u, then what you've got left, u to the 4th, that becomes your outside function. That's this one. That's the outside. Let me write that out. So here's the outside function. Here's the inside function. Okay, so should we try this again with a slightly more complicated function? Yes, sirree, Bob. I don't know where that expression came from. I don't use it except in my videos. I get inspired by spirits of the past. Let me make a much smaller u. Look at this. No expense is, I forget the word, but we don't spare any expense when making these videos. I have a crack team of graphic designers putting this stuff together. Okay, so we've got another function, and we got to figure out who's on the outside and who's on the inside. And this is sine of e to the x. Now here, the of pretty much tells you the sign is on the outside, and of e to the x means e to the x is on the inside. What's your other clue? Your other clue is that e to the x is inside the parentheses, and that's almost always going to be a great way to figure out who's on the outside, who's on the inside. So there's the e to the x on the inside, and here is the sign, and the sign kind of goes all the way around, if that makes sense. because it's sine of whatever's inside the parentheses. So our inside, I'm going to do this backwards. Okay, we're just going to agree to do it backwards. Right? Just because that's the way it's happening, right? Woohoo, we can be flexible. We're not just rigid mathematicians, right? This is totally okay. I won't need to go to therapy after this, totally. Okay, so u to the x first, because that was the one that I thought of. That's the inside. That's going to be my e to the x, whatever's inside. Just like the u of x was the 3x squared minus 5x. That was what was inside there. Okay, now, since that's my u, I'm going to put my u over the top of that. And then my other function, g of u, is going to be sine of u. What do you guys think? Kind of woohoo? I think the u is kind of brilliant. I'm giving myself a gold star. Woohoo. Gold star for me. Woohoo. And you guys can have part of the gold star too, because you guys are watching. So it's gold star for you too. Gold star for us. Yay. Okay, so that was the first page. And we're at 6 minutes, so I'm just going to keep going. So feel free to pause, go get something to drink, maybe review this part, because now we're going to go on to actually using this, what we've just done, to find the derivative. Okay, so if you need to take a pause, take a pause. I'm just going to keep going because I'm going to throw caution to the wind. Here we go. You guys are brilliant, and we can totally do this. Okay. Dun, dun, da, da, dun, dun, da, 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 da. Calculus. Da, da, da. Calculus. Do, do. Oh, no, it should have been chain rule. Do, do, do. Okay, so the next is going to be that we use the chain rule to find the derivative of each function from the first page. And then I wrote this, which honestly, I think a lot of the rules in calculus are written in ways so that if you already understand what's going on, it's really clear and beautiful and brilliant. But when you're trying to learn it, it's just a lot of apostrophes running around and you know, parentheses and brackets. And so I don't know if it's especially helpful. But the important thing is that you have to take turns. And if you remember with the product rule, right, when two things are multiplied, you do the derivative of one, but then the other one stays plain. Then you add, the first one stays plain, and then you take the derivative of the second one, right? So you have to take turns. That's the product rule. The chain rule has a very similar rule. We're going to take turns. So what happens is to take the derivative of the expression, you take the derivative of the outside. So it's the outside derivative there, right? But then the inside stays plain. It's plain inside. And then the inside gets to take its derivative. So this is the derivative here. This is the derivative here. Notice the interesting thing is there is no plain f. So it's not purely taking turns. F and U are going through different experiences, as it were. So there's no plain f. There's just derivative of f. But then you put normal u inside, and then you take the derivative of u. Okay. Shall we give it a try? So with f of x, now this was the very first one we did on the previous page. So this is the one we're playing with right here. Hopefully you have the notes for that, or maybe pause and go back if you need to refresh your memory. But we had this rule that said f of u was u to the fourth, and that's the outside. And then the inside, the u part, is the 3x squared minus 5x. And a lot of people at this point, they're like, why do you bother with the u's and the x's? Well, the answer is not all books do. Not all people do. Some people do it without u at all. They just do all of x's. And, you know, I would encourage you, talk to me after class, talk to the tutors, say, hey, can we just try it without any u's? We just use x's. That is a different way to approach it. And, if that might work better for you. So definitely I encourage you to look into other methods, because this is not the only way to look at the chain rule. Okay, so first thing I'm going to do is I'm going to say, what is the derivative of just f prime of u? So in terms of u, forget that x exists. There is no x. There is only u. It didn't quite work. Zul and u almost sound the same. Okay, so this is just going to be the power rule, right? 4 comes down, u stays there, and I subtract 1. Oh, pterodactyl. Pterodactyl. I don't have my pterodactyl. You gotta pretend that my hand is a pterodactyl. Instead of writing 1, I wrote 3 because my brain's like, we're going to do 3. And I'm like, yes, good brain. But you jumped the gun. Okay, so there's that. Now let's look. And now what we're going to do, pretend f doesn't exist. Just you. There's only you. You are the only one here. And you are so precious and special. And so is this u. So let's go ahead and take the derivative here. So the derivative of u, let's see, the power rule says the 2 comes down, so we've got 3 times 2x to the 2 minus 1, minus, and then remember 5x, if it's just an x, you just leave the coefficient, so just 5. Technically, it's 5 times 1 if you want. You don't have to write it. So this is going to be 6x to the first power minus 5, so that's 6x minus 5. Okay, so far so good? Woohoo, you guys are doing awesome. I'm very impressed. I'm very proud of you. We're going to do it. We can do this. Okay, now, what is the chain rule? The chain rule says, first you want the derivative of f with u inside of it, and then we multiply times the derivative of u. Well, so f prime of u of x times u prime of x, which is going to be ultimately f prime of x, that's going to be 4u3, right? So this is our, I forgot to put in my colors. Oh my goodness. Where would I be? There's our derivative. There's our derivative. Here's our derivative right there. And then we're going to have our derivative of u prime, which is going to be right here. It's going to be our derivative. So that's going to be times, now 6x minus 5, it's 2 terms, so I'm going to have to put in parentheses. Now, technically, in some worlds, I'd be done. But the problem is I want the derivative of f at x, and I've still got this u running around. And so what I'm going to do is I'm going to replace the u. What was u? What was u? These expressions are so funny. U was 3x squared minus 5x. This is, remember, this is plain u, not derivative of u. So this is going to be plain u, 3x squared minus 5x cubed, 4u cubed times 6x minus 5. That's our final derivative. Now, I am sure that a lot of you are like, yeah, I'm not going to do all of this to take a derivative. And the answer is no, you won't. As you move on, you'll get better or more confident. When you feel more comfortable with the process, what you will do instead looks like this. But you'll still be thinking in these same ways. If I see this f of x, so this will be a big or, f of x equals 3x squared minus 5x to the 4th power. Okay, so if I want to take the derivative, what do? Well, I think outside is the 4th. So I think the 4 comes down. I do not change the inside. The inside stays the same. But the 4 came down, and what's the rule? The rule is I subtract, I was going to subtract 3 again. My brain, trying to be helpful, not succeeding. Okay, well, so this should be 4 minus 1, not 4 minus weird arrow t, whatever that is. And then I multiply, and then the inside gets its turn, where I get 3 times 2x to the 2 minus 1 minus 5. So this is the derivative of the inside. So that's going to be 4 times the quantity 3x squared minus 5x cubed times 6x minus 5. And through the magic of television, we're going to compare. Did I get the same answer? You can't see because my camera doesn't go that far. But did we get the same answer? Woohoo! We did! Yay! I took you to Smearytown. Sorry about that. But we did get the same answer. So you can either approach it really formally like this, or you can approach it just kind of doing it in your head. And what I would hope is that after a while, you practice a bunch like this rhythm starts to make more sense, so that will help you pick up speed. Because when you're doing calculus problems, this is just going to be the first part. Then you're going to do something with the derivative. So you want to try to make sure that your derivative doesn't take you half an hour, right? Okay. You guys ready to try another one? Yes. Okay, great. That's awesome. Dum, dum, dum. Here we go. So g of x is equal to sine. Remember, it's sine and not sin. Sine of e to the x. And I want to make sure I have my piece of paper, so I set this all up as beautifully as I did the last time. My g of u from the first page, where to go? This first page where we've got u of x. Oh, and I forgot to, let me quickly fix this. Make this blue. Sorry, no, it's our secret. I forgot to color everything. I gave myself a gold star and I didn't even color it. What is even happening? Who's in charge here? Okay, so we got g of u and u of x. Let me copy this down. G of u is going to be sine of u, and then u of x is going to be e to the x. Okay, let me move us over so you can actually see what's happening. That makes it more exciting. So this is our original blue. This is our original outside. And here's our original inside. Now for each one, I'm going to take a derivative. So g prime of u. Remember, I pretend there is no x. There's only u. And I think, okay, what's the derivative of sine? Derivative of sine is cosine. There we go. No muss, no fuss. Then, I know this one looks scary, but it's got the easiest derivatives. I picked this because I was feeling like, oh, we need a treat. So, u of x equals e to the x. Do you guys remember what the derivative? This one is the best. I remember being like, really? Okay, let's just do e to the x always. The derivative is e to the x, which is, I know, a little bit confusing. It's like it's its own grandpa. But basically, it describes itself. It's pretty cool. The graph describes its own derivative or its own tangent slopes, which is just so cool. Okay. So again, what did I do? I got my outside. Speaking of outside, someone outside needs maybe a new belt or possibly new brakes. Sorry about that. Here's the inside. Then I took the derivative of each. Now I'm going to put it together into a lovely, delicious casserole of derivatives. So the derivative of g of x is going to be the derivative of g of u of x times the derivative of u of x, right? So this is going to be our blue derivative. And this is going to be our yellow derivative. Woohoo. So our blue derivative is going to be cosine of u, and I'm multiplying by my yellow derivative, which is going to be e to the x. And you'll remember that this is technically correct and fine, except that I'm asking for x, so we have to convert the u. And so, oh, here, let me do my yellows and my blues before we convert. Make sure everything's all pretty. Derivative, derivative, derivative. Feeling like this conversation is very derivative. Okay. So what is u? Now we have to go back to perhaps the first, oh, no, we don't. It's right there. I've got cosine, which is the blue derivative, right? But inside of the cosine is the u, the original u. So it's the derivative, right? Because sine went to cosine, but the original u was e to the x. So that's the original u. Now, in this case, it's pretty cool because our original and our derivative are exactly the same. So what's the derivative? Also e to the x. Now, technically, you could write it as cosine of e to the x times e to the x. Honestly, I frequently usually see it that people have tucked the e to the x at the front. So it looks like this. You won't be off if you don't do it that way. It's just this is convention. And there you go. Woohoo. We did it. You guys are amazing. Woohoo. I think not just a gold star, but maybe a cobalt star. It's not quite cobalt. What is that word I just said? Cobalt? Cobalt? Okay. Yeah, it seems that my brain needs a little bit of a break, maybe. It's very excited and maybe needs to calm down and drink some tea and reconsider my life choices. But you did it. That was a lot of math, but hopefully this helps to make the Jane rule make a little bit more sense. Definitely take a break. It's been 22 minutes, so you and I both have to go and touch some grass or look at some sky, or at least get away from a screen for a moment. Please remember to drink some water. Make sure to get enough sleep. Make sure to take care of your precious selves. Your brain is just riding around in your body, so you can fill your brain with lots of math, but you got to take care of the part that carries it around and takes care of it. So, get something tasty to eat and maybe go, do an interpretive dance about derivatives. Maybe e to the x being its own derivative. I mean, that is profound. And know that I think you're amazing. And math on and woohoo and math on.